Hello everyone, I am P. Manoj Kumar, Assistant Professor at G. Pullareddy Engineering College, Kurnool. So welcome to the ETABS tutorial series. In this video, I am going to tell about the analysis of simply supported beam subjected to UDL and concentrated loads. So for this analysis of simply supported beam, I am considering one simple example of having 8 meters of length, 8 meters of the length from here to here. We are having total length is 8 meters, and in this beam we are going to apply 30 kilonewton load, concentrated load at a distance of 2 meters from the end A, and 20 kilonewton load, concentrated load at point D, which is acting at a distance of 4 meters from the left end, and also one more load is acting, that is uniformly distributed load, which is acting over a length of 4 meters from the right support. So this is the example that I am considering to analyze this simply supported beam. So with the help of ETABS software, right? So for this, first we need to make the grids for this analysis of beam. So actually we are having 3 axes in ETABS. This is X, this is Y axis, and this is Z axis, right? So in X axis, first I am going to considering the grids in X axis. So here I am considering at support A, I am considering one grid. So this is my grid A, and this is grid C, this is grid D, and this is grid V, right? So this is about the along the x-axis we are considering 4 grids, and in y direction only one grid we are having, that is this one. This is 1 grid. So with the help of these grids, we will prepare the, we will make the model in ETABS software. So for that, first we need to open the ETABS software. After that, we need to click new model. So here we are having 3 options. In the previous video, I have already explained regarding these 3 options. So initially I am for this analysis of beam, so I am choosing third option. So with this third option, you can change this display units. So whatever the display units you need, those things you can select. Here I am selecting metric SI system. After that, I am selecting Indian steel section database, and steel design code is IS 800 to 2007, and concrete design code is IS 456 2000. Next, click on OK. So here you'll get one simple new window regarding the templates of the grids. So here we are having one option is uniform grid spacing. So in here we do not have any uniform grid spacings in our beam, so that you can go to the custom grid spacing. So here you can customize your grid spacings with the help of this custom grid spacing. Then click edit grid data. So here you'll get one more new window. So you'll see what are the grids that we are having. See, first grid is A grid, and then so we are having C, D and B grids we are having, right? So what is the distance from the A to C grid? Those things we can provide in our ETABS software, right? So here I am choosing this display grid data as ordinate, and for grid A, that is starting from 0. 0 is my origin grid, that is A. And next you can see here we are having C grid at a distance of 2 meters from this A grid. From this A grid, those things we need to enter over here. So 2, enter. This is C grid, right? I am changing this grid name as C, that is C. Okay. Next grid is D grid, that is again it is located at a distance of 4 meters from the A grid. Those things only we need to give. Whatever the origin point we are having now, with the reference of that origin point, we need to give the distance of the any grid, right? So here D grid is there. Here I am renaming this one. This D grid is located at a distance of 4 meters with reference to this A grid. Okay. Next, last grid, that is B grid, and this is located at a distance of 8 meters from point A. So those things here you can see. These are the grid data on x-axis. Again on y-axis we are having only one grid, that is 1. Here I am remaining grids I am going to click delete option. So these are the only one grid that we are having. See here you can see. So in this screen you can see this, we are having on x-axis we are having 4 grids, that is A, C, D and B. On y-axis it is only one grid, that is 1. So if you want, you can change this grid bubble size to avoid the overlapping of these bubbles, so that I am going to decreasing this value. So here you can see the bubble size is decreased. Again I am giving 800. Okay, still it is overlapped. 700. Okay, so this is enough. Okay, so next I am going to click OK button. Now in y-axis, in stories, how many number of stories we are going to use? Only one story. So then after giving this one story, again you just go to custom story data and click edit story data over here. So here you can have only 2 stories, that is base and story 1. So in ETABS there is one point, that is at least a minimum 2 stories we need. So to make the model in ETABS software, so that is base and story 1. So if you want to, if you are trying to delete this story 1, so it cannot delete. So that is the reason I am telling that. So minimum we need base story and story 1 to make the model. Okay. So now click OK button. Then you can enter into the main window. So here you can see there are 2 windows are there, that is plan view window is this one, and 3D view. Here I am going to close this window so that you can see clearly this plan view story. So but after getting this plan view, you just go to the elevation view from this, so that I am clicking one number and applying to this window, so that you can see from the elevation. From the grid 1 you can see all the elevational grid points. So this is my base. Here you can see, here we are having base story and here it is story 1. So with the help of this grid, I am going to create one model of this simply supported beam. Okay, so for this, first I am choosing this beam cursor. So just click on this beam cursor and go to the grid joint, grid point A, and click left button to connect the beam. So here, from here to here I am giving one beam, and from here to here again I am clicking second beam, and third beam is this one. So you can deselect this beam option. So now we have already created one beam. So for this beam we need to give supports. So at grid A1, at this A1, we are having one support and one more support is located at B. So these things we need to assign the joints for these joints, right, at these joints. So you can see here at the left support we are having one hinge support, and the right support here we are having roller support. Those things here I am going to assign to these joints. Here just I am clicking on this left joint, that is at A. So next go to the assign option, joint and restraints. So here you just select the hinge option. Here we are having 4 options. One is fixed support, second one is hinge support, third one is roller, and this one is none of the support. Okay, here I am choosing this hinge support and applying over here. So here you can see this is the hinge joint, and at the grid B, at grid B, I am going to assign roller support. Here you can see apply. So these are the joints already assigned to this beam, right? Now our next step is to assign the loads over this entire beam, right? So for this you just go to this diagram. At grid C, what are the load that we are having? At grid C we are having 30 kilonewton load exactly acting at this grid C. So here you can assign the load at this joint, so you just go to assign and go to the joint loads. So why we are choosing this joint load means exactly whatever the 30 kilonewton load that we are having, that 30 kilonewton load is exactly acting at the joint, right? So on the joint. So for that reason here I am choosing the joint load, and this joint load is concentrated load. That is the reason I am choosing this force option. And here I am giving live load. Load pattern name is live load. So here you can see this is the Z. It is in vertically we are having Z axis. So for that reason in the force global Z option only we need to provide the 30 kilonewton load that is acting towards the downwards. That is the reason I am giving minus 30 kilonewton load after selecting this joint. So if you after clicking this apply option, then you can see that 30 kilonewton load towards downwards it is showing. It will show. See, this is the 30 kilonewton load exactly acting at C, right? So one more load is acting at point D. So at point D 20 kilonewton load acting, right? So that is the reason again I am going to choose the joint D and giving minus 20 kilonewton load. Next apply button. So then you can see this is the 20 kilonewton load which is acting towards downwards on the beam, right? So next load is UDL. That UDL is acting from point D to point B. So that entire this span we are having this UDL load, right? So for that reason, so this is one more beam, right? So member load it is, that is frame load. Member load means frame load. So just select the beam and go to assign. Next go to the frame loads. Next go to the distributed loads. Why? Because this is a distributed load, now uniformly distributed load. That is the reason I am selecting this distributed load. So here also I am choosing a simple live load. So dead load I am not at all choosing over here. Why? Because if you are considering the if you are giving the loads on the dead load, that self weight of the beam also will be considered, right? That is the reason here I am choosing only live load. And here you can see, so live load load type and direction, force it is, that means it is force, and direction of load it is gravity load, and trapezoidal loads. So if you are having uniformly varying loads, those things also you can give with the help of this one. But here we are having UDL over the entire span of this dB, right? that means it is not partially loaded, right? That is the reason here I am choosing the uniform load. If you are giving this load over here, load of 10 kilonewton per meter over here, so whatever the load that you are given over here, now the entire load will be distributed throughout this beam, throughout this selected beam, right? You can see I am clicking apply button. See here, you can see this is the entire UDL acting over the beam, right? So now we have already provided all the we have already assigned all the data, that is joint loads, and here you can see I am showing the joint loads also too. So here joint loads we are having, also we are having uniformly distributed load over here. So here I am showing that those things also, right? Frame load, so live, okay, right? So see here the concentrated load of 30 kilonewton and 20 kilonewton load acting at point C and at D. Also we are having uniformly distributed load over the span of dB, right? So now we have created model and we have applied loads. Now we need to analyze this beam. So for that, go to analyze, next check model. If there are any warnings are there, it will show you, otherwise it will show you like there is no warnings in this analysis of simply supported beam. So now model has been checked, no warnings messages were generated. Then click close button, again go to analysis and run analysis. So by clicking the run analysis, it is asking to save your file. So here I am giving simply supported beam example 1, save. Now it is analyzing the beam. Now you can see, see this is the deformation of the beam, that is deflection of the beam. So now for this simply supported beam, if you want to see the reactions of our end supports, for that you just go to display option, then force or stress diagram, then support or spring reaction. Then here we have applied all the loads in the live load option, right? That is the reason you just select live load option. Instead of giving this live load, if you select this dead load, it won't show anything, right? Go to live loads, and reactions is acting towards the along the Z axis, right? That means vertically. So that is the reason here I am choosing FZ. Then click apply button. See here, you can see this is the reactions of our supports, left and right supports, right? So this is how you can see the reactions of our beam. Or else if you want to find if you want to see the shear force and bending moment diagrams, then go to display option, again force and stress diagram, go to frame or pier or spandrel. Or else you can see here also same icon is there. Here also we are having same icon here and here. So directly you can click this option too. Directly you can click this option too. Same dialog box will be open, right? So here if you want to see the shear force diagram, then you need to click shear to 2, shear to 2. Then if you want to change the display options, you can change over here fill diagram or show values at controlling stations on diagram. First I am showing this fill diagram. Click OK. Right else. Here you can see. Here you can see. This is the shear force diagram. This is the shear force diagram for our beam. And again, if you want to see the values, you just click this option, show values at controlling stations on diagram, then again apply. Right, you can see, here you can see, this is 42.5 minus, this is minus 12.5 kilonewton, and this is 47.5 kilonewton of shear force we are having. Next, if you want to see the bending moment diagram, then go to moment 33, And same thing, if you want to see the fill diagram, you can click on fill diagram option, then apply. So this is my bending moment diagram. This is my bending moment diagram. Or else if you want to see the values at the control station, then click second option. Then you can see this is the bending moment diagram. So now if you want to see the entire thing, loading diagram, shear force diagram and bending moment diagram, you just do one thing. You just go to the beam and click in your mouse, right? Then here you can see this is the thing that you can see. Here what happened means, so we have divided the entire beam into 3 parts. That is the reason here you can see part of the beam only. So if you want to click this one, then you can see. So this is the dB span, and the dB span, here you can see the shear force and bending moment diagram. So this is how you can make the entire simply supported beam analysis. Or else we are having one more method, that is you can join the beam from point A to point B directly. That is also no issue. So I'll show you that option also. For that I'm going to choosing one more new model, or else I am going to delete all these options or modifying this entire beam, right? So to modify this analyzed beam, you need to unlock the model first. So then click unlock button, then go to OK option, then you just delete this entire beam, delete the beam. So here I have deleted all the beam. If you want to, you can see the any loadings are there is no loads, right? So right now again for the same grid I am going to do the analysis of the simply supported beam by making only single beam from A to B. Here I am making direct beam from A to B option. So here now you just see there is only one beam. Here under this left bottom corner you can see one frame is selected. That means from point A to point B we are having only one beam. But in previous case we have divided the entire beam into 3 parts. One A to C is one beam, C to D is one more joint, and D to B also having one more beam. Instead of that, you can do only one beam for this entire A to B point, right? So after adding this beam, you just assign the joints, go to assign joint restrainment and hinge, apply. So select one more joint over here and go to roller support, apply, close. Now we have created supports to the beam. Now we need to apply the loads at point C, load at point, concentrated load at point D, and uniformly distributed load over the entire span of D to B, that is 4 meters, right? So in previous case, we have given joint loads. Why? Because we have created the beams from A to C, C to D, D to B. So for that reason we have given joint loads. But here that will not be considered as a joint loads, right? So for that you just choose the beam. You just select the beam and go to the assign option, then go to the frame loads. Why we are choosing the frame load means we are giving the loads in between of A and B points, right? That is the reason we are going to selecting the frame loads and go to the point loads. Again live load. So at a distance of 2 meters we are having one gravity load. So here we are having two options. One is relative distance from end 1 and one more is absolute distance from end 1, right? So what does mean by relative distance? For example, I'll show you in the PPT. So what is relative distance? Relative distance What does mean by this relative distance means? So if you want to apply our 30 kilonewton load at a distance of 2 meters from point D, so in that case you need to give the relative distance. That means whatever the distance, at what distance this 30 kilonewton load is acting, that distance you need to consider over a length of, what is the total length of the beam? 8 meters. So 2 and 4, 1/4 distance we are having. That means our relative distance is 0.25. So by giving this 0.25 only, this 30 kilonewton load will be acting at point C. If you want to apply the 20 kilonewton load at point D, you need to calculate the relative distance at point D. What is the relative distance? What is the total distance from A to D? So from A to D we are having 4 meters. And what is the total length of the beam? 8 meters. Then you need to calculate the relative distance for point D, that is 0.5. And these by giving this relative distance values only, you can apply the 30 kilonewton load and 20 kilonewton load by giving this relative distance values. So this is how you need to calculate the relative distance. See here. So at 0.25, what is the value that we are having? Or else you can give all the zeros over here, not total necessary. So here I am giving 0.25 is a relative distance from end 1. And what is the load is acting? 30 kilonewton load. 30 kilonewton load, right? So and one more point is 0.5 is my relative distance. At 0.5 relative distance, what is the load acting over here? 20 kilonewton load. So now by clicking apply, you can see those two values will be appear over here. See here at point C and at point D, and both values are added over here. So this is how we can apply the concentrated load with the help of relative distance from end 1. So if you are using absolute distance from end 1, you can directly give the distance, what distance it is acting, you can directly give that distance only. So with the help of that distance only, you can assign the loads. So this is the difference between this absolute distance and relative distance, right? So I'll show you this option also. So instead of that, I'm selecting this beam and deleting the existing loads, right? Now I'm choosing this absolute distance option and giving, I'm trying to give 30 kilonewton concentrated load and 20 kilonewton concentrated load at a distance of 2 meters and at a distance of 4 meters. So at a distance of 2 meters, my 30 kilonewton load is acting on the beam, and at a distance of 4 meters, my 20 kilonewton load is acting over here. So with the help of this second option, that is absolute distance from end 1, so this is how you need to give the you need to assign the loads. You can see by clicking apply button. Okay, now I need to select the beam. So after selecting that beam only, we need to give the loads. See here. So this is the major difference between the relative distance from end 1 and absolute distance from end 1. These are the two major differences you can observe over here. Okay, now I need to choose the beam first for giving this UDL. Again I need to go to the assign option, frame loads, distributed loads. So in previous case only one load is one separate beam we have created, right? So for that reason we have given 10 kilonewton load over here, but here that is not applicable. Why? Because my beam is acting from point A to point B, but in this beam at a distance of 4 meters, at 4 meters distance, it is the UDL started at 4 meter distance from point A and continued up to the point B, right? Those things we have to give in the ETABS, right? So first here you can see distance where it is started, where our UDL is started on the beam, right? So at a distance of 4 meters, at 4 meters distance, our UDL is started, right? With an intensity of, oh no, you need to select the absolute option here. You just go to the absolute option again. So at 4 meters distance, our UDL is started with a magnitude of 10 kilonewton per meter and continued up to this end point B, right? So that is up to 8 meters. Up to 8 meters, we are having same intensity of load, right? Now you can see after applying the load, you can see in the beam, right? So this is how you can apply the loads. So the major difference between the two cases we have already discussed. One is you can make the beams in individual V, that is from A to C, C to D and D to B. But here I have created the entire single beam and applied all the loads over here. Now you just go to the analysis, analyze option, check model, select all, click select all button, then click OK. See, this is the no warning message window. Go to analysis, run analysis. Then you can see, so here I want to see the reactions of the supports. Then go to live and apply, close. Same values you can get over here. See here. So in previous case also we got 42.5 kilonewton and 47.5 kilonewtons. This is the reactions of the simply supported beam. And next, if you want to see the shear force diagram, then go to the frame load options and go to the shear 2 option, then click apply button, or else you can see fill diagram option. So this is how you can see the complete diagram. If you want to see the shear force and bending moment at a time, including the loading diagram, you just go to the beam and click right button in the mouse, then you can see. So this is my loading diagram and this is the shear force diagram and this is the bending moment diagram for this loading condition, and this is last deflection. So if here you can see, if you go to the scroll for values, wherever you want, you can place that scroll option, then you can see this is the shear force diagram. Or else if you want to find out the shear force and bending moment at a distance of 4 meters, then give 4 meters over here and click enter button. Then you can see this is the shear force diagram and this is the bending moment and this is the deflection. This is the deflection. Or else if you want to find out the shear force and bending moment at a distance of 4.5 meters from left hand, then you just give the 4.5 over here, then you can see the shear force and bending moment diagram over here. Or else if you want to find the shear force and bending moment at a distance of 6 meters, this is the 6 meters. At this 6 meters distance, we are having 27.50 kilonewton as your shear force and 75 kilonewton meter as our bending moment. This is the deflection, 3.38 meters. So this is the this is how you can make the model, and this is how you can analyze the simply supported beam, right? So thank you.